So in this video, we are now going to start trying to get access to the domain controller. So previously on the last video, we installed a persistent backdoor and also showcase how to create a pivoting to enable for us to enumerate the internal network. So we're just gonna run flyby to it in here. Make sure that SSH is enabled on our box, and also I will make sure that our shell is stabilized. Port pty.spawn /bin/bash export term. So I'm just gonna up here. I'm just looking for the previous commands that we enter. So here it is. Password 123. So, and our SSH RS shuttle. And our SSH to proxy chains. So right now everything is set up. We have now access to the internal server using this compromised machine, which is a web server. So I'm just gonna open here our new tab. This is gonna be our new working tab here. So the next step is to actually perform Nmap scan to the machine. So if you remember from the previous video, we already run scan sh 168.45 that, and this will show us the host that is running internally. So in case here, this is actually the web server, and this is right now unknown to us, but this is going to be the gateway. So we are much more interested here on this IP. So we're gonna perform a stage Nmap here. So first I'm gonna run proxy chains on port 445 for the meantime. This is for me, this is the best way to identify if it's a domain controller, and also we will try to scan on port 88. We don't want to run a full Nmap scan here, because we know from our experience on trying to exploit the web server, they have an IPS that keeps us getting blocked. So we are assuming that there is some kind also of internal network segmentation or some kind of intrusion that might detect us. So we don't want us to get flagged and lose our access. So there will I've done this before. I've experienced getting blocked by the IPS. So we might lose also this pivot shell, but we're just gonna redo it. But hopefully we will not encounter those kind of disconnection in this demonstration. But yes, in a real world scenario, that might happen. So okay, so the scan is finished. So we have here important informations that we have gathered using our scanner. We have identified that the computer name is server 2016. The net BIOS name is the same server 2016. The domain name rnetworks.com, same with the forest name, and we have the fully qualified domain name. So this information should be added to our host file. So I already added it, but I'm just gonna show it to you. So this is the entry. So make sure you have here server 2016 rnetworks.com, server 2016. I don't know why I add DC1, but yeah, basically these are important information here, because this is going to be important when we're going to use in-packet tools for further enumeration of the host. So I'm just gonna close it one. So another one to verify if it's really the domain controller is to make sure to see if port 88 is running or listening. The host is listening on port 88. This is actually the Kerberos service. So while waiting for that, I'm just gonna go back to the home page. So if you remember on the first video, we recovered a seems to be a valid user. So right now I've already created a user. So yeah, based on the Nmap also, it shows that port 88 is open on the server. So I've already created also a user.txt file here. It's not here, but I'm just gonna create another one. So I'm gonna add a.page. It's also gonna add administrator, admin. So these are just some kind of user that you can try, but you can also try having a username list from your libraries, but we don't want to create a big noise trying to enumerate a large file of usernames. So we're gonna stage our enumeration here. So I already have here. So the next tool that we're gonna use is I'm just gonna drag this one because we're gonna use it for later. So is the curve root. So this is the syntax. So user enum is our flag here. The -dc would be rnetworks.com, and the domain is the rnetworks.com. It's basically the same, and also you have to supply the file here. So the ID, this tool will actually return to you if the user is actually existing on the domain. So we just run it. So hopefully we're still in the network. So yep, we can see here that admin at rnetworks is a valid user. Also administrator is a valid user. This is also one thing to make sure that your syntax is correct. Is usually this user will be valid. And we see here that a.page rnetworks.com is a valid, and also you see here we recovered a hash file of her password. So what happened here is the account or the settings for a.page has this settings enabled. It's called disable Kerberos pre-authentication. I'm gonna show you it about when we're already the domain controller admin. So I'm not going to crack this hash file because what we're gonna get is this is called ASF roasting. So this is actually the one that is going to be crackable by a hashcat here. So this is part of the impacket library. So this is gonna be the syntax here. So basically, the curve root is going to be our tool to enumerate valid users. So once we have valid users, we can then move into ASRep roasting. From here also, it also shows that the account of a.page is ASRep roastable. So just gonna run it again. And this is going to be the one that is crackable via hashcat. I'm not sure how to crack this one from the curve root, but I never succeed on cracking this one, but this one is easily crackable if her password is on the racu.txt. So I'm just gonna copy it to my local machine. I've already copied it, so it's on crack.txt. So the syntax is hashcat and 18,200. So this will come from hashcat examples. So basically we're gonna look for this value. So that's actually I tried everything, so you can also try everything there. What's gonna work for Kerberos cracking, but for hashes that come from the get np users.py will be crackable using this flag here 18,200 and supply the file and also your word list. So I've already done this, so we're just gonna use show. So turns out that the password is on the racu.txt. So it's let me in please. Now we have recovered password of Alice. So I'm just gonna put it here and a.page. So another thing to share this to, if you're not able to crack this hash or you're not able to have recovered some kind of hash here is to try to get more information with this username. So this is actually also already a big username because it's already showing on the home page, so you can perform some kind of OSINT. So one thing you can do is check for where is it? So I will already open it. So check for have I been pwned. So we have here the user, so we can just change the domain here. Let's say gmail.com. So it turns out that this email, although it's a different domain, but you can say that this could be related to the user. You can see here that the Gmail account is part of a breach happened in 2018, and let's expose usernames and also a PBKDF2 password hashes. So I'm gonna show you how to get those files because that's going to be out of scope here. Basically, you will get those files from different kind of hacking websites, but another one is the paste bin. Some people just pasting information here like breaches, passwords, and usernames. So but we're not gonna find a that page here, but yeah, if you recover some kind of users, you might want to check here and then try the password that is written here. So for example here, Govindrati107, and has the password of Govind107. So, and another way is to actually run crackmap.exec. So I'm just gonna close it. So crackmap.exec. So basically, this is a tool that will try to run different password or username depending on the supplied file on it. So, but we're not gonna do that because we're also concerned of bringing a big noise on the environment, so we might get flagged and lose our access. So fortunately, we still have valid access here. So since we have already recovered the password, we can now run crackmap.exec and verify where do Alice have access. So I think it already flagged it there. So I already changed this password. So that's the original password that I wanted to use, but I just changed it because it's not. So I'm just gonna paste it here. So basically, in this syntax, it will try to check if Alice.page has access to the SMB share of the domain controller. So let's just run it. And yep, the syntax is correct because it identified the server to be server 2016. This is actually also crucial when you're trying to connect, because we're gonna use the domain name, the host name itself, the net bias name, when trying to connect to the SMB share. So hopefully we're still connected because we might get flagged by the IPS. But all these transactions is running on SSH. So basically, these are all encrypted. It's not returning something here. So while waiting, let's just run another crackmap exec here, making sure also that so from here, so I'm just gonna close this one now. We have, it turns out it's a valid credentials for accessing the SMB file share. So let's just run SMB map now. So a.page, and the password would be let me in. So this is trying to enumerate what's gonna be our permissions on the file share. We don't have SMB map that day, but why is that? We still have access. Let me in, please. 2, 3. Let's see. 5.5. Let's try running it on proxy chains. We're getting error. How about let's change this one? Server 2016. So this will get translated from our host file. Let's just see if we still have access here. Okay, yep, we still have access. It's turning. So I'm just gonna check my host file. Sudo sublime /host. So it should be correct. Server 2016. Let's see. It's saying authentication error, but we have here crackmap exec says that we have access. Well, anyway, the best way to test that is to just run this. So it just kind of shows it here now. SMB client, it should be -l list to list, and our password is this one. I'm gonna enter the password here. So hopefully we still have access here. So I think we got in. So I'm just gonna check on our IPS if we get flagged already. So it's not here. So this is the domain controller. So I already have access here. So I'm just gonna it's kind of biased thing because I already have this password here and it's incorrect. Third 2 3. So I'm just it's not showing all the file share here. Did we just lose access here? Nope, it's not. Let's try running it on proxy chains. So what I want here is to make to list all the file share that is available on this SMB client. Why it is not returning? So yep, we are not on the blacklist here. So of course we can see that we are still connected here. Now my concern is why it is not listing all the file share here. It should list the shares here. So yep, this one, proxy chains work and we're able to identify the file share. So this will also indicate that this is really a domain controller because of this share name, netlogon, and the sysvol. So we saw here a public share, so we can try to access it. So by just adding here public and just give our password again, which is this one. No, don't die our pivot shell. So I'm gonna input our password here. So now this is going to be our next job here. Why is it my S shuttle is not working correctly? 0.5, it seems correct. Let's see. I'm just checking for something here. So yep, we got inside, and then if you try to list the file here, so we have here a note to Alice. So we now identify the name of a.page. It turns out it's alice.page, and we can exfiltrate this data since let's try get alice.txt. note. So we are able to get the file and cut. So it says here, so I just basically add this clue here. So please put all resume here. I'll review them as soon as I'm available. Ricardo, regards Ricardo. So turns out that we can drop a file here, and this another user named Ricardo will try to open it. So what if we try to put a malicious file, let's say a malicious Word file that will execute that might execute malicious commands. So I have here already a created one. This is something that I learned during my PWK experience, so I'm just gonna open it. So this is basically a Libre-Office file, .odt file, and I've added here a macro. So in order to produce this macro, I used this MSF venom command. That's it. So it's showing here. So basically, create a reversal, and the file is hta-pish, and output it to evil hta. And if we open it here, evil.hta, so we will get this file. But what we are interested here is this PowerShell.exe-nop-w hidden in and unencoded base64 commands. So we cannot just simply put it here, because from what I learned, already open it here, VBA has a 255 character limit for literal things. But this restriction does not apply to strings stored in variables. So this script will make this base64 encoded to look like this one. So this is actually requirements for this macro. So if you run it on this one, if you run it python transform.py, so basically we get here the strings. We can just copy it and just paste it on the command here, and make sure to add this on the header, cmd-exe and -c, to make sure this is going to be executed on a command prompt. So if what happens if we put that file here, so I'm just gonna show you back here that, so we have created a listener, a reverse shell going back to our host. So this one is different, but it should be 8.223. So we've already done it, and the port is 443. So if we clear his and nc, actually need sudo, and let's put our resume there. So okay, so it's just slow right now. I'm not sure why, but so it was successfully put there. And the reason I use Libre-Office, because if you try to use Microsoft Word, we still need to like register for something. So I don't want to do some kind of that anymore. So if we go to our domain controller, let's see, where is it? So this is actually logged in as Ricardo. So turns out that this is the file share here, assuming that this is an actual user, and try to open the file. So this is the file that's uploaded here. We should be able to get a reverse shell. We did not. Why is that? Let's see. Oh, it's connected now, so it just got a little bit of delay. So if we try, so from here we really need to be very careful, because this traffic is going to be unencrypted and can easily be get flagged by the IPS when someone's trying to do something malicious, since we enabled a lot of rules on the Suricata IPS. So what I'm interested here is the user. So first of all, I'm just gonna c/users, cd/users, so dir. So we have here r.manual cd to that folder. So I don't want to try to type like something who am I or something like something that's trying to enumerate something of this host running on this reverse shell. So from here we will try to exfiltrate a lot of more information here as our user here. So we can actually go to its desktop and dir. Turns out that there's a file here, a folder here, an elastic agent. So they could be enabling some kind of CM here, SIEM, which using Elasticsearch. So from inside here, we can find here a Elastic Agent config.yaml file. So if we type that file here, we can recover a password here on the top. Turns out the user is Elastic, but this password can be reused, right? So I'm just gonna save it on our notes. So we recovered another password here. We still don't know our user, but our possible user could be r.manuel. So I'm just gonna wait, hold on, just gonna check again here. So anyway, I'm just gonna exit here because I've already done this a lot of times. I'm usually get flagged on. So yeah, right now we are flagged already. So I'm just gonna show that what's happened here. Yes, let's try open the suricata here. So that's the danger of having a reverse shell which is unencrypted. It's easily get flagged by an IPS rules. So I'm just gonna log in here. So what we can do from here is just to try again to change our password, and we created a persistent backdoor, but it's going to be pointing on the blocked IP address. So if we go to our suricata here, services, suricata, on blocks. So this is what I wanted to tell you. So turns out it's easy to identify those kind of reverse shell and easily gets blocked on the IPS. So you can also see it here if there's some kind of it's a Trojan network was detected. So it's running on the port 443 if you remember our reverse shell, and it's a malware Windows dir. So this is the command that we execute. So what we can do is just go back to the first video where we try to root the web server again from the web page, but not gonna show that it here. I'm just gonna cut the video and just reestablish this reverse shell. And also I'm gonna clear this blocking just for the sake of discussion. I don't want to change my IP back and forth. I'm just gonna clear this one, but I already show you that might happen if you're trying to run reverse shell and unencrypted reverse shell. So I'm just gonna clear this stuff. So okay, with the power of editing, I've already reestablished our reverse shell. I mean the pivot here and also the S shuttle. So I just stopped using these proxy chains anymore because we're not gonna do further Nmap here. We're just gonna run native tools, and it will automatically redirect it to this IP address with this S shuttle here. So remember we already recovered the password here, so we can run actually crackmap exec. So what we can do here is try to change here Manuel, and the password is this one. Let's try. This should not work because so we have a special character here. So what we're gonna do is, I'm having problem with that, so I'm just gonna use a pass file here, pass.txt, and just gonna paste the password here. and instead of pasting it here, I'm just gonna call the file there. So turns out it's wrong credentials. So you can go back here again. Let's see what other permissions as a.page have. So we know SMB is okay, but let's see if we can actually remote access using Windows Remote Management here. So turns out user Alice has a remote shell access for the web server, but we still don't know the credentials of r.manuel. But let's just put this password for a while. We'll come back right here if we might find some user. So I'm just gonna, it's not the correct one. I'm just gonna connect back to, I'm just gonna use evilwinrm here, -u a.page. So it's just showing here all the passwords that I have tried before doing this recording. So hold on, let me show you also. We can actually run Bloodhound here. So it's not that one. And there's a lot of spoilers here. Bloodhound. So this is actually where I'm getting at. I'm gonna try to run Bloodhound and try to get a wider view of the domain controller. So we can run it using this file page. Copy this one. So let's just try if it's going to run. So server 2016 should be server 2016. And also another way, so I'm getting an error here. It could be that a.page cannot get a proper query on LDAP. So what we're gonna do is just upload a file here. I'm just gonna show you. Already have it here. It's the file sharphound.exe. So I'm just gonna cd. I think this is a correct file already. So before that, I'm just gonna cd to Bloodhound to make sure that when I uploaded the file, downloaded the file, is going to be on a different folder. Go back and upload. I'm just gonna upload this one. This is the directory and the file. Just gonna close this one. So this binary is basically the same as this command here. It will try to get query, but now it's running inside the machine. So if we try to run that one, sharphound.exe, it's just gonna do its thing. So it's gonna create its own query inside the box, and we will be having this. We will have this file. So right now we are interested in this file, so we can just download it. So Bloodhound is another Active Directory enumeration tool. So I'm just gonna show you here how to use it. So I'm just gonna open a new tab here. So we have here the file, unzip. Already done it. And I'm gonna open now the Bloodhound. So we're gonna upload all this JSON file. Did it get unzip? It did not. Unzip that here. /la. Why it's not get unzip? File. Unzip. Okay, that works. So we have here JSON file. So I'm just gonna run sudo neo4 jconsole. This is going to be the database for the Bloodhound, and if it's done, I'm just gonna run this binary here. So enabled locally. So started. It's gonna run Bloodhound here. Let's just wait for it to load. So I've already done it. I'm just gonna clear all the database that is in here. Let's see, clear database. So that we can upload the new one here. Where's the file manager here? Documents, home lab, our networks, internal, Bloodhound. So basically you just drag and drop all this JSON file here, and let's finish, wait for it to finish before. So this will give us a better overview of how the domain controller is configured. So it's finished. So first thing to do is always make sure that a user is already flagged as, I'm just gonna close this one. What do you mean really? So we can flag here as owned because we have already access to this one. So we can try here different queries. So reachable high targets. So it's gonna show you different mapping here, and also what kind of method that you can do to escalate our privilege here. So I'm not gonna go through everything of it, but what we're interested here is find principals with DC sync rights. So if we hit here, check for the domain controller, it gives you actually a big output. How to minimize this? So where are we right now? So where are we right now? Let's see. Should be paid up page here. So we see here b.joel our networks has I think this is the one that shows it, has help. Let's see help. So the user b.joel has the DS replication get change all privilege on the domain R networks. Basically the user has capability of performing DC sync rights. So DC sync attacks is basically using his account. It will try to reach to a domain controller and saying, hey, I am also a domain controller and I want to connect to the domain, so give me all the hashes. So we recover a new user. Another way to recover here is, let's see if it's gonna work. Also trying to RPC client. I don't know what are those, but this is for a different box that URL 45.5, and another one also is this one. Let's see if we can actually get in using so we did. So another one is enum dom users here. So we also recover here different usernames, and if you get a lot of list here, I'm doing a also, let's see, query this info. This one can also try this because sometimes user have a description. So this one turns out Bob Joel is part of is an IT administrator. So yep, so this is basically all the users in the domain, and we have here information that Bob or Billy b.joel is part of, has a capability of DC sync, right? So, and remember, going back here, we recover a password. We can actually try if it's b.joel credentials via crackmap exec. So I'm just gonna exit this one, and let's just try it. It's valid user. So I'm not gonna use that one because it has these weird characters. So I'm gonna pass that cd dot. I'm on a different folder where my password.txt is. pass.txt. So turns out that the password here is for Bob Joel. So basically he is an admin, and we recover this password on an elastic agent.yaml file. This is going to be a password reuse. So he's using this password on their Elasticsearch CM. So this is just gonna matter of time. Let's just perform this async attack using secret-dumps.py. I've already done it. So basically this is the syntax. So when we do this, we're gonna supply also the password here. I'm just gonna put it on my clipboard, and this should give all the hashes. So we now recover the hash of the admin and every domain users on the domain rnetworks.com. So now we can just perform a pass the hash attack to get an admin privilege on the domain controller. So I'm just gonna exit on this one. So I'm gonna type administrator here and change the flag -h, meaning this is gonna be a pass the hash attack. And hopefully, yep, we get now an access. So from here we can actually perform different kind of commands, because remember this is running on an encrypted traffic. So who am I /priv and ID. Let's just make sure that this is really the domain controller. This is the IP here, and yep, this is basically the end of this project. We successfully gained access to the domain controller. So stuffs to make persistent access here is basically just doing a golden ticket attack, but we're not gonna do that here. That's it.